Hello and welcome to Algebra 2 Lesson 36. In this video, we're going to learn about special products. So again, we've come to another scenario where if you've taken Algebra 1, this lesson is nothing more than a refresher for you. But it's an important refresher because we're going to look at polynomial products that occur so frequently that it's extremely useful to memorize the pattern associated with these products. And you might do it just to be faster on your homework or on your tests, but I can tell you when you start taking these standardized tests like the SAT, the ACT, or even if you're going to grad school, even if you've graduated from college already, you want to take your GRE or your GMAT or whatever you're taking, those tests are designed with a time limit that in some cases requires you to be able to spit out these products very, very quickly, okay? So this is just something you can use to do that. So I want to start out with something that's very, very basic, something that most of you know. So if I have something like the quantity x plus y times the quantity x minus y, we can say this is equal to x squared minus y squared. Now first I want to do this with FOIL, and then I want to show you why it ends up this way and how we can translate something generic like this to our actual problem. So if I did FOIL here, if I did x times x, that would be x squared. Then if I did x times negative y, that would be minus xy. Then if I did y times x, it would be plus xy. And then if I did y times negative y, I'd have minus y squared. So what happens with this, the middle two terms are going to cancel. And I'm left with x squared minus y squared. So this is x squared minus y squared. So you're looking to make sure that you have the same term in the first position of each binomial. So I have an x and an x. I've got to have different signs. I have a plus and a minus. And then I've got to have the same term in the second or last position of each binomial as well. I have a y and a y. So if it fits that pattern, you can go ahead and say that you have the first guy or the first item that's going to be squared. Then we're subtracting away the second or the last guy squared. And this is referred to as the difference of two squares. I have something squared here minus something squared here. So as another example, let's say you saw the quantity v plus 1 times the quantity v minus 1. Well, again, I think about this is v, this is v. So same item in the first position of each. Then this is 1, this is 1. Same thing in the second position or last position of each. Then I have a positive and a negative, so I have different signs. So without going through and doing FOIL, I can say I have the first guy, which is v squared. That's what I have there. Subtract away the second guy, which is 1 squared. 1 squared is 1. So I get v squared minus 1. And again, if you want to prove this to yourself, you can use FOIL. V times v is v squared. The outer would be minus v. The inner would be plus v. So we know those would cancel. And the last would be negative 1. Right? 1 times negative 1 is negative 1. So again, these cancel. I end up with v squared minus 1. All right, let's take a look at some more examples. All right, so let's say we had something like the quantity 8a minus 6 times the quantity 8a plus 6. So it's the same thing here. I have 8a and 8a. Then I have 6 and 6, and your signs are different. I have minus and I have plus. So I don't have to go through and use FOIL. I can do this very, very quickly by just squaring 8a. So 8a squared. Okay, you've got to be careful that you're squaring this whole thing, this whole term here. I can't just do 8a squared like that. I see that all the time. That's not going to work. I've got to square that whole term. So I would square 8. 8 squared is 64. I would square a. That's just a squared. Then minus, I'm going to look at my 6, and that's going to be squared. 6 squared is 36. So just that quickly, without doing FOIL or anything else, I know my answer is 64a squared minus 36. And again, we can prove it to ourselves. 8a times 8a is 64a squared. The outer, 8a times 6, would be positive 48a. The inner, negative 6 times 8a, would be minus 48a. And then your last, negative 6 times 6, would be minus 36. So again, you can see that these middle two terms are going to cancel. Positive 48a and negative 48a would cancel. So 64a squared minus 36 is what you are left with. So just a much quicker way to do this versus using FOIL. All right, let's take a look at another one. So we have the quantity negative 6x minus 3y being multiplied by the quantity negative 6x plus 3y. So again, I'm looking at a negative 6x here and a negative 6x here. I'm looking at a 3y here and a 3y here. Now, the signs are different. I have a negative and I have a positive. When I do my pattern, again, I'm thinking about the first thing that occurs. So this right here. Normally, I'm not including the sign when I'm thinking about the second one. In this case, I need to include that negative when I think about negative 6x. I can't just leave it off. So I would square that. So if I squared negative 6x, it would look like this. So that negative is inside the parentheses, so it's basically negative 1 squared, which is 1. 6 is squared. 6 squared is 36. And x is squared. X squared is just x squared. So this is 36x squared. Then I'm subtracting away. What is in the second position here? It's 3y. Again, when we think about what's in the second position, I never think about the sign. I just think about this right here. So 3y. If I squared 3, I'd get 9. If I squared y, I'd have y squared. And boom, there's my answer. 36x squared minus 9y squared. Just that quick. But again, on this one, kind of the trap is to make sure that you include the sign when you think about that first term. All right, let's take a look at one more of these. So suppose you had the quantity 4u minus 7v, and you multiply it by the quantity 4u plus 7v. So I would take this guy right here, this 4u, and I would square it. So 4 squared is 16. U squared is just u squared. Then minus, take this guy right here and square it. 7 squared is 49. And v squared is just v squared. And then again, boom, just that quick, I have my answer. 16u squared minus 49v squared. So again, we're kind of done with this section. I just want to recap and talk a little bit about this for a second. You're looking for this pattern where you have the same thing in the first position of each. In this particular case, it's 4u and 4u. Then the second position of each has the same thing. So 7v and 7v. And then your signs are different. You have a negative and you have a positive. So that leads to this. The first guy, which is 4u, squared, minus the second guy, which is 7v, squared. So you just memorize that pattern. You can put it on a flashcard or something where you can flip through, memorize it. And as you do your homework, as you do your tests, as you get into your standardized exams, this is going to be very beneficial for you. All right, let's look at a different section now. All right, so the next thing I want to talk about is the square of a binomial. And we have two different scenarios. So we have the quantity x plus y squared. This leads to x squared plus 2xy plus y squared. So notice that when you have a plus sign here, you have a plus sign here and here, okay? So if I have this scenario, I don't need to really think about the signs. Everything's going to be a plus. Now in the other scenario, we have the quantity x minus y squared. I have x squared minus 2xy plus y squared. Here, I have a minus in the middle, and so that leads to a minus in front of the second term. So everything else is the same. It's x squared minus 2xy plus y squared. The terms are the same. It's just this one sign that's different, okay? So it's very easy to memorize this one, and it's very easy to apply it. Let's take a look at an example. All right, so we start out with the quantity 3x minus 8, and this is squared. So this is a binomial squared. So what would I do here? Well, let me just write the pattern that we should know. So if we do x minus y, that quantity squared, it's the first guy squared. So it's x squared. Then remember, we have a minus in front of the second term because we have a minus here. Then it's 2 times x times y. Then it's plus this guy squared. So y squared. So just match that pattern, okay? So if I take the first guy and I square it, so 3x and that's squared. Again, you've got to make sure you square the 3 and the x. Then we would subtract away. You have 2 multiplied by x times y. So x and y just represent the first term and the second term here. So 2 multiplied by 3x multiplied by 8. Okay, then the next thing we have is plus y squared. So I'm going to add to this whatever's in the last position, which is 8 squared. So 8 squared. And this may take you a few times to kind of get it down, what represents what, but x in this case is the first term, so that's representing 3x here, the first term. Y represents the second term. Here that represents 8 because 8 is the second term. Okay? So once we've set that up, let me erase this. We don't need this anymore. We will say 3x squared with the parentheses around the 3 and the x. 3 squared would be 9. Then x squared is just x squared. And then we're subtracting away. We have 2 times 3 times 8. 2 times 3 is 6. 6 times 8 is 48. And then times x. And then lastly, plus 8 squared is 64. So we get 9x squared minus 48x plus 64. And just really quickly, I'm going to prove to you that this works. And I'm going to show you how much longer it takes. So if I had 3x minus 8, that quantity, if it's squared, I'm multiplying it by 3x minus 8 again. Don't make the mistake of saying the quantity 3x minus 8 squared is equal to 3x squared minus 8 squared. That's wrong, okay? Please don't make that mistake. This has to be expanded out. All right, so once we have in this format, we can use FOIL. 3x times 3x is 9x squared. The outer, 3x times negative 8 would be negative 24x. The inner, negative 8 times 3x would be negative 24x. And then the last, negative 8 times negative 8 is positive 64. You can see you can combine like terms in the middle. So you would end up with 9x squared minus 48x, right? Negative 24x minus 24x is negative 48x, then plus 64. Now, you can see that this answer is the same as this answer. We just got this answer more quickly because we used a pattern, right? We recognized how we could get the answer. We applied it. We got it very quickly. All right, let's take a look at another one. So we have 7n squared plus 8, that quantity, and it's squared. So again, if I think about x plus y, that quantity squared, this would be what? The first guy squared, so x squared, plus 2 times x times y, plus the last guy squared. And so the way I actually remember this, I take this guy and I say, okay, this is squared, and I know this is squared. So that goes at each end. Then I remember my exponent is 2. That's involved in a multiplication in the middle. So I just say, okay, well, I have 2 times x times y. That's how I get the middle part, 2xy. That's what works for me. I'm not sure what will work for you, but you can certainly try that. Now, if I go through and try to apply this, again, I have to match things up. So in this case, x, which is the first term here, represents 7n squared, which is the first term here. So those match up. Then y, which is the second term here, matches up with 8, which is the second term here. So those match up. So what I'm going to do is just say, okay, in this one I have the first term squared. So 7n squared will be squared. Then plus, I have 2 times the first term times the second term. So 2 times 7n squared times the second term, which is 8. Then plus y squared. So it's the last term squared. In this case, that's 8. So 8 squared. All right, so let's erase this. And let's just crank this out now. So if we have 7n squared squared, 7 squared is 49. N squared squared, power to power rule. So n stays the same. Multiply 2 times 2, that's 4. Then plus, you'd have 2 times 7 times 8. I can do 2 times 7 first, that's 14. 14 times 8 is 112. So this would be 112, and then times n squared. Then lastly, plus, if we have 8 squared, that's 64. So we end up with 49n to the 4th power, plus 112n squared, plus 64. All right, let's take a look at another one. Let's suppose we had x minus 4y, and this quantity is squared. So I'm going to write out my pattern, and I'm going to go with x minus y, that quantity squared. So we should know at this point it's what? It's x, the first term squared, then minus. Remember, if you have a minus here, you have a minus in front of the second term. 2 times x times y. 2 times x times y. And then plus the last term squared, y squared. So just apply that here. The first term squared, so x is squared, minus 2 times the first term times the second term. So 2 times x times 4y, and then plus the last term squared, so 4y squared. Okay, we can erase this now. We don't need it. And so we'd have x squared minus 2 times 4 is 8. So you'd have 8xy. And then plus 4 squared is 16. Y squared is y squared. So you get x squared minus 8xy plus 16y squared. All right, let's take a look at one more of these. So I have the quantity negative a squared minus 9b, and this is squared. Now, this one's a little tricky, and I'm going to get to that in a second. Again, if I have a subtraction in the middle, I use this formula. So x minus y, that quantity squared. This is x squared minus 2xy plus y squared. Now, what makes this tricky is this negative right here, this negative a. Normally, we have a positive there, right? We don't think about our signs. We just use whatever's there. If you have a negative here, you've got to account for that by putting it in, okay? So that's what makes it tricky. A lot of students will say, okay, I'll just put an a squared in there. Or a lot of students will throw this negative in there when they think about 9b, right? This sign right here in the middle is already figured in for you. So you never need to use it, okay? You never need to think about it. If I have a negative that's thrown at me there, though, I do need to put it in, okay? So that's the difference. So what I want to do here, I want to say I have the first guy squared. So the negative a squared, the whole thing. So that's going to be squared. Then I subtract away 2 times the first guy. Again, I've got to put the negative a squared in times the second guy. Now, for the second guy, I never include that negative or that subtraction sign out there. I just take whatever's in that position. Just like here, I just take y, right? I don't put negative y in. So you've got to follow that formula to the T. I'm going to put 9b in there. And then last, I'm going to have plus this guy, 9b squared. So 9b squared. All right, let's erase this. And let's crank this out. So if I have negative a squared squared, I know this is basically negative 1 squared. That would be 1. So this would be positive. And then a squared squared, keep a the same, and multiply exponents. 2 times 2 is 4. Then next, we would look at, we have negative 2 times negative a squared times 9b. Negative times negative is positive, so I know this would be plus. And we think about 2 times 9, that's 18. And we'd have a squared times b. So a squared b. Then lastly, we have 9b. That amount squared. So plus 9 squared is 81. B squared is just b squared. So we end up with a to the 4th power plus 18a squared b plus 81b squared. So just something you want to look out for is when they throw these signs at you. If you put a negative out in front of that first term. Okay, so pay close attention to that. All right, so the last thing I want to talk about is when you have a binomial cubed. So this one's a little bit more tedious, but this one will also save you more time. Because as you multiply more terms, it gets more tedious, it becomes more easy to make a mistake, and it takes you longer to do the process. So memorizing these will have the greatest value for you. So if I have the quantity x plus y and it's cubed, I get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, if I have the quantity x minus y and that's cubed, it's the same thing, only the second position and the 4th position have minus signs in front. So x cubed minus 3x squared y plus 3xy squared minus y cubed. Now, in terms of memorizing this guy, it's a little bit more complicated. I always just remember that I have x cubed and y cubed at the beginning and at the end. So that's easy. Then I know I'm multiplying with a 3 in each of the 2 middle terms. Just like when we looked at the square of a binomial, I knew I was multiplying by a 2, and it was 2 times the first term times the second term. That's pretty easy to remember. Here you have a square involved in each case, so it's kind of goes back and forth. But if you just remember that the first term is squared in one case, the second term is squared in the other case, so it's 3 times one of these squared times one of these to the first power in each case. In the first case, we have 3 times the first term squared times the second term. Then we have 3 times the first term, which is not squared, times the second term, which is squared. Okay? And then the only difference between this one, where we have a plus, and this one we have a minus, is the minus sign in front of the second and fourth terms. And again, I know this seems daunting, but you work 10 or 15 problems looking at this and representing it and going back and forth, you're going to have this down, and it's going to save you a tremendous amount of time. All right, let's look at an easy one to start. So let's suppose we had x plus 3, that quantity cubed. Well, what's going to happen, again, if I put the quantity x plus y cubed, what is this? Again, I know I have x cubed in the beginning, and I know I have y cubed at the end. I know that I have 2 terms in the middle, and I know it involves multiplication with 3, right? So 3 and then 3. Now, all you need to remember is that I'm multiplying by the 2 terms here. One of them is squared in each case, one of them is not. So if I start out by just saying, okay, x would be squared, y is not. Then if I say, okay, now x will not be squared, y will be squared. Boom, got my answer. It's just that simple. So I'm just going to apply that technique here. So I have x plus 3, that quantity cubed. So the first guy is cubed, so x cubed. The last guy is cubed, so 3 cubed. Let me put that all the way down here. Now, I'm going to have 3 multiplying by these 2 terms for the 2 middle terms. So let me put that in there. And then in each case, one of them will be squared, one of them will not. So I'm going to square x. 3 will not be squared. Then I'm going to square 3. X will not be squared. And that's it. I've got my answer. It's really, really that simple. All right, so let's erase this. And you can see how much quicker this would be versus kind of expanding this out into x plus 3, that quantity, times x plus 3, that quantity, times x plus 3, that quantity. This will take a while, okay? Doing it this way is going to be much, much quicker for you. All right, so we have x cubed to start. Then we have 3x squared times 3. 3 times 3 is 9, so plus 9x squared. Then we'd have plus, you have 3 times 3 squared times x. So 3 squared is 9, 9 times 3 is 27, 27 times x is just 27x. And then lastly, plus 3 cubed, which is 27. So we get x cubed plus 9x squared plus 27x plus 27. All right, let's look at another easy one. So we have the quantity x minus 2, and that's cubed. So can we do this without writing out the pattern? I think that we can. So again, I know that I want this first thing cubed, so x cubed. I know that I want this last thing cubed, so 2 cubed. And I'm going to go ahead and write that as 8. We know 2 cubed is 8, so let me write that all the way down here. Now, as far as signs go, I know in front of the second term and the final term, or the fourth term, I have minus signs. So there'll be something here, there'll be a plus sign, and then something here. Now, what do we remember? We remember that these 2 middle terms here have a 3 that's leading. So let's put a 3 in each case. And I'm multiplying by each term here. It's just that one of them will be squared in each case, one will not. So we'd start out with x being squared, and then 2 not being squared. Then we'll have x not being squared, and 2 being squared. Boom, and we're done. It's just that easy, okay? So we have x cubed minus 3 times 2 is 6. 6 times x squared is 6x squared. And then plus 2 squared is 4. 4 times 3 is 12. 12 times x is 12x. And then minus 8. We're done, okay? And again, think about how much time that saved us. And we had to go through and do the pattern. I could just kind of do this mentally and have this answer in a few seconds, okay? And you'll be able to do that too. So if you're on a standardized test and it asks you for the quantity x minus 2 cubed, you can get that answer in a few seconds and kind of move on. Versus somebody that's got to take out scratch paper, expand this into the quantity x minus 2 times x minus 2 times x minus 2. They might be there for a full minute, okay? So you're ahead of somebody by a full minute now. That's time you can apply to a more difficult problem. All right, so let's look at one final one of these. It looks a little bit more complicated, but really it's not. We have the quantity 6z minus 4x, and this is cubed. So again, what am I going to do? I know that I want this first guy cubed. So 6z, I know I want that cubed. I know I want this last guy cubed. So let me throw this all the way down here and say we have 4x, and that's cubed. I know that I'll have a minus sign in front of the second guy and the fourth guy. So I'll have something here. I'll have a plus sign and something here. Let me kind of move that down a little bit so it's more even. And I know that I'm going to have a 3 that's multiplying the two middle terms. Now, in each case, one of the terms, when we talk about the middle terms, will be squared. One of them will not. So I'm going to multiply this by, I'll have 6z squared times 4x. In this case, I'll have 6z not squared and 4x as squared. And that's it. Now we just have to go through and do some calculations. So 6z cubed, the 6 is cubed. 6 times 6 is 36. 36 times 6 is 216. Z cubed is just z cubed. Then we'd have minus. So then we'd have 6z squared, which is basically going to be 36z squared. And 36 times 3 is 108. Then if I multiply by 4, I'd get 432. So minus 432. You would have x and then z squared. So xz squared. And then plus, you have 3 times 6z times 4x, that amount squared. So this right here would be 4 squared times x squared. We know 4 squared is 16. So let's write 16x squared for that. So 3 times 6 is 18. Then 18 times 16 would be 288. And you'd have x squared z. Then lastly, you have minus. You have 4x cubed. 4 cubed is 64. And then x cubed is just x cubed. So we have 216z cubed minus 432xz squared plus 288x squared z minus 64x cubed.